Hello friends, welcome to Triple tutorial channel. In this video, we are going to see the construction of three-phase induction motors. We know that induction motors are commonly or widely used in industries. Almost 80% of its mechanical power is used by the industries. The construction of induction motor is very simple when compared with DC generators or that kind of generators, that kind of electrical machines. And low cost operating characteristics is good, and commutator is absent so that the speed regulation is very good. Like transformer means due to induction the power is developed at the rotor. So we will discuss about that working principle in detail in the coming video. Here we will discuss only about its construction. Okay. The speed of induction motor is normally less than synchronous speed, that is so that these induction motors are also known as asynchronous motor. Okay, if the machine which is rotating in synchronous speed, then it is synchronous motors. But here the induction motors will run always the speed just below synchronous speed. Hence they got the name asynchronous motor. So now let us see the construction of three-phase induction motors. For the construction of three-phase induction motors, we need essentially two parts. They are nothing but a rotor and stator. So first, stator. Stator means it is the stationary part of the induction motor. And the stator windings are connected or placed in the stator. And we will provide or we will give three-phase supply to the stator winding. Okay. And a rotor is nothing but the rotating part of the induction machine which is connected to the mechanical load. Okay, that is the major points about stator and rotor, basic points about stator and rotor. And based on the construction of a rotor, the three-phase induction motors can be two types. That is squirrel gauge induction motor or second one is slip ring induction motor. Slip ring induction motors can be also called as wound induction motor or phase wound induction motors. Okay, so these are the two types or the two classifications of induction motors, three-phase induction motors based on the construction of a rotor. Okay. In addition to stator and rotor, we need some more requirements. Here you can see the sectional view of a three-phase induction motor. Here we need a drive shaft. Here you can see the drive shaft which is made up of steel which will transmit the torque to the load. Okay. And the next we need bearings. Bearings, the function of the bearing is to support the rotating shaft. Okay, fan is needed for cooling purpose because more heat will induce in the induction machine. So in order to cool, we need cooling fan. Terminal box which is connected for receiving the external electrical connection. And air gap is provided between the stator and rotor in order to induce EMF in the rotor. So the gap or the air gap is normally ranges from 0.4 mm to 4 mm. This range or these points are very important for technical exams, objective type exams. So let us discuss about the construction of stator in detail here. We know that stator is the stationary part or the static part of the induction motor. Not only in the case of induction motor, in every machines, stator is the stationary part of the machine. Okay. The stator consists of stator frame, stator core and stator windings or field windings. So let us discuss about stator frame here. stator frame is the outer body of the induction motor. Okay, in this diagram you can see the outer body, and this outer body is nothing but the stator frame. Its function is to support the stator core. We are placing the stator core inside this stator frame. So the function of stator frame is to support the stator core and field windings. So that we can see that this stator frame will act as a covering and which will provide the protection to the inside parts. Okay, they are normally made up with die-cast or fabricated steel. Next, second part of the stator, that is stator core. Stator core is placed inside the stator frame. You can see here. Function of the stator core is to carry the alternating flux. In order to reduce the eddy current losses, these cores are normally laminated. The thickness of the laminations are normally ranges from 0.4 to 0.5 mm thickness. And some stampings are laminated in order to reduce the eddy current losses. They are formed together to form this structure, that is stator core. That means stampings are collectively known as stator core, or simply we can say that they are normally made up with silicon steel. Silicon steel is used because of to reduce the hysteresis losses. Normally 4 to 5% of silicon can be added in order to reduce the hysteresis losses. So that to reduce the eddy current losses we can laminate these stampings, and in order to reduce the hysteresis losses we can use silicon contents. Okay. The third part of stator, that is nothing but stator windings or simply field windings. Okay, these stator windings or field windings are placed on the periphery of the stator core. So you can see here this brown colored portion indicates the stator winding or field winding, and we are providing three-phase supply through this terminal box to the field windings. Okay, so three-phase supply is given to the field windings or simply stator windings. Okay. Okay, these are the major things about the construction of stator. And remember that based on their construction, we know that there will be two types of induction motors, slip ring and squirrel cage induction motors. Normally, we will start the squirrel cage induction motors by using star delta starters, so that the construction of the field windings are normally delta connected for squirrel cage induction motor. Okay. So for squirrel cage induction motors, the stator are normally delta connected, so that we can remember that point. Okay. But for slip ring induction motors, they start by using resistance so that it can be either in star or delta. These 2 points are important for technical exams. You can remember that points. So okay friends, now let us discuss about the construction of rotor. We know that based on the construction of rotor, there will be two types of induction motors, slip ring induction motor and squirrel cage type induction motors. So here we will discuss about the squirrel cage type induction motors. So in this type of rotors, it consists of cylindrical rotor and which is having slots on its periphery. Here you can see rotor bars. These slots are not exact parallel, because they are made just skewed in order to reduce the magnetic locking, and this will make the smooth operation. Okay, so that the rotor bars are not parallel to each other, they are made just skewed like this. These rotor bars are normally made up of aluminium, brass or copper. At the end portion of this rotor bars which are joined together by a ring that is known as end rings. Okay, both the ends are short circuited by using end rings, so that we can see that rotor conductors or simply rotor bars which are slightly skewed in order to prevent the magnetic locking, and they are permanently short circuited. Okay, these points are very important for your technical exams. Okay, since they are permanently short circuited, means since the copper conductors of the squirrel cage induction motors are permanently short circuited, it is not possible to add external resistance. Okay, in addition to this, slip rings brushes are absent in this case, so that their construction is very simple, robust, and since they are widely used. Okay, so based on this, we can see the advantages of squirrel cage induction motors. Its construction is very simple and rugged. Due to the absence of these brushes and slip rings, they are having less maintenance. And the disadvantage of squirrel cage induction motor is that starting torque is very less, but starting current will be very high. Due to this high starting current property, the squirrel cage induction motors are normally used in lathe drilling machines, fan blowers, printing machines, etc. That means where the region we need high starting current, there we can use squirrel cage induction motors. Okay, these are the main points about the construction of squirrel cage induction motors. So now let us discuss about the second type induction motor, that is slip ring or wound rotor or phase wound three-phase induction motors. Okay, here you can see the construction of slip ring type rotor. Okay, here in addition to the squirrel cage induction motor, here you can see brushes, slip rings. So due to the presence of these slip rings brushes, we can add external resistance to this slip ring induction motors. Thereby we can control the speed. So speed for where we need to control the speed, there we can use slip ring induction motors. In addition to this, all other points are very similar as that of squirrel cage induction motor. Okay. So slip ring induction motors consist of slip ring brushes to connect external resistance to improve the speed and to control the speed and to improve the starting torque. That is the important difference of between these two induction motors. Okay. Now let us see the advantages of slip ring induction motors. In slip ring induction motors, they are having high starting torque and low starting current. We can add external resistance to control the speed, and we can easily control or to improve the starting torque. So these are the two major advantages of slip ring induction motor, or we can say these 2 points are the major disadvantages of squirrel cage induction motor. Due to that disadvantage, we developed slip ring induction motors. So because of their high starting torque, they are mainly used for hoisters, cranes, elevators, etc. That means where the region we need high starting torque, there we can use slip ring induction motors. Okay. So based on these points, we can compare the slip ring induction motors and squirrel cage type induction motors. Okay. So first, here you can see the points about slip ring induction motors, and here will be the points about squirrel cage induction motors. We know that the construction of squirrel cage induction motor is very simple, and so they are commonly used. The construction of slip ring induction motors are not easy, so that because of the presence of slip ring and brushes. This is the first point, basic comparison. In squirrel cage induction motors, rotor bars are permanently shorted, but for slip ring induction motors, rotor winding construction is similar as that of stator winding. Okay. In squirrel cage induction motor, we cannot add external resistance because they are permanently short circuited. But for slip ring induction motors, it is possible to add external resistance. Okay. Then the next point is, for squirrel cage induction motors, starting torque is very less but starting current is very high. But we cannot improve the starting torque for a squirrel cage induction motor. But for slip ring induction motor, it is possible to improve the starting torque by adding external resistance. Okay, and it is possible to improve its speed by adding external resistance. But all of these points are not possible in squirrel cage induction motors. Okay, slip rings and brushes are absent in squirrel cage induction motor, but both of them are present in slip ring type motor. Maintenance is very less for squirrel cage induction motor because the absence of slip ring and brushes. But for slip ring induction motor, need frequent maintenance. Okay. Due to the simple construction, squirrel cage induction motors are widely used, but due to the difficulty in their construction, the slip ring induction motors are rarely used. And based on the copper loss, we can say the efficiency is very less for squirrel cage induction motor. Sorry, efficiency is very high because of its less losses. Copper losses are very less. Okay. But for slip ring induction motors, efficiency is very less because of the presence of more copper losses. Okay. And speed control is possible for slip ring induction motor, but not possible for squirrel cage induction motor. Okay. These are the major classifications of squirrel cage and slip ring induction motors. So, in this video, we studied the construction of three-phase induction motor. Mainly, we studied the construction of stator and rotor. Based on the construction of rotor, there will be two types of induction motors, and these are the major comparison of that two induction motors. Okay, these points are very important for your technical exams, so you can remember these points. So in the coming video, we will see the working principle of three-phase induction motors. Okay, hope you like this video and thank you.